Hello everyone and welcome back to our videos. Today we are gonna talk about fuel valves. Fuel system use many types of valves such as pressure valve, and we use a relief valve, and flow valves, and we use selector valves, check valves, and shut off valves. Here they specify the selector valves. The selector valves are installed in the fuel system to provide a means of shutting off the fuel flow for tank and engine selection, for crossfeed, and for fuel transfer. The size and number of ports opening vary with the installation. How that's come? If you back to the gravity feed system, you find our selection valve have 3 positions. When you also talk about pump feed system, you find that we have 2 ports. So the size and the number of ports depend on the system that we are using the selection valve on it. Valves may be hand operated, motor operated, or solenoid operated. Valves are accommodate the full flow capacity of the fuel line, must not leak, and must operate freely. A manually operated valve must have a definite or a click when it's in the correct position. Now we have 3 types of operated our valves, such as selector valve or shut-off valve. They will operate for a hand operated or motor operated or solenoid operated. The first one we will talk about is the hand operated valves. Hand operated valves may be found on small and medium sized aircraft and will likely be either cone type or bobbit type selector valves. So we have 2 types of hand operated valves. The first one called cone type and the second one called bobbit type selector valves. All fuel systems provide for shutting off the flow of fuel from the tank to the engine, and most of the smaller aircraft use hand operated valve. The simplest valve is the cone type, and this cone type is the first type of hand operated valves, in which a cone usually made of brass fits into a conical races in the valve body. The cone is drilled so it will allow flow from the inlet of the valve to any one of the outlets that is selected. A detent blade is installed on the shaft that is used to turn the cone, and a spring-loaded pin slips into the detent when the hole in the cone is accurately aligned with the holes in the valve body. This allows the pilot to tell by feel when the valve is in any given position. Here we have this figure. This our cone type. Here we have the construction: handle, detent plate, spring, brass cone, and valve housing. Here we have the inlet and here the outlet. So when you handle this, the squeeze of the cone will open and the spring will allow for the detent plate to open the cone. Here it's open, but when it's closed you will turn this handle and this will close, and the hole here it will be removed and it will stuck the inlet to go through the outlet. In this type there is a problem, and this problem in this valve is that they can become difficult to turn. So the handle is tough. It needs a power from a human to move it. Now the second type of valves or hand valves is the bobbit. The bobbit type valves overcomes this problem by using a camshaft operated by the selector valve handle to open the correct bobbit and control the flow of fuel through the valve. The positive shut off fuel is provided by spring on the valve, and it is easy for the pilot to tell by feel when the valve is centered in the selected position. Here when we say this our bobbit valve, and here we have our camshaft. When you turn this handle, the camshaft will oppose or will move this rod to go up, and the fuel it will come from the inlet and goes to the outlet. The spring here, when you turn this and the camshaft come to this position, the spring will move our bobbit valve to close the valve. The second type of operated valves on a fuel system is motor operated valves. Larger aircraft must use remotely operated valves in the fuel system. There are two basic types of remotely operated valves in popular use today: those driven by electric motor or those operated by solenoid, here operated by a motor. And there are two types of motor operated valves, and one of them is called motor drive drum. This is the first one that has a hole cut in it. This is so fuel can flow through a drum when it is in one position and is shut off when it is rotated 90 degrees. The other type is the motor driven by sliding gate. The gate is drawn to let fuel through a shut to stop it, like this figure. Here we have our gate, and here we have a sectional view of our pump or of our valve. This the motor, and here the shaft of the motor. When the shaft rotates, it will leave or it will make this arm to goes up, and when this arm goes up, it will move the gate to up position to arrive to this position and will open for fuel goes. When you want to close it, you will motor opposite direction and the gate will close down. The last type we have is the solenoid operated valve. Solenoid valve has the advantage over the motor driven valve of being much quicker to open or close. When electrical current momentarily flow through the opening solenoid coil, it exerts a magnetic pull on the valve stem to open the valve. When the stem rises high enough, the spring-loaded locking plunger of the closing solenoid is forced into knotic in the valve stem. This holds the valve locked open until current is momentarily directed into the closing solenoid coil. In this figure, we have a solenoid operated valve. The construction of this solenoid, it consists of opening solenoid, closed solenoid, and opening solenoid control wires, closed solenoid control wires, spring in the two rods, and fuel inlet and fuel outlet. How this will operate? We have a current or electrical power will go through the wire to the solenoid. The solenoid will rise up this rod. When this rod raised, the second rod by spring will close our rod and will make this rod opened. When this rod opened, the fuel will flow from the inlet and goes to the outlet. In the event I want to close this flow, I will send a signals or electrical power to the closing solenoid control wires. When this comes the power to here, it will move this to the back because it's solenoid, and this by spring loaded will goes down and close our valve. This the solenoid valve.